Now, how do you go on solving such an integral? Chances are, if you have already taken statistical mechanics or quantum mechanics, you may have already encountered one such integral. Integration by parts can actually be used, but using gamma function makes things a bit easier, right? So more on the gamma function thing a bit later in the video, but first let us try to simplify this integral. Notice that the integrand that we are using is actually an even function. That is because if we replace x with minus x, nothing changes, right? So I can use the property of definite integral and write this integral as 2 times integral from 0 to infinity of x square e to the power minus ax square dx. Let us try to substitute. Let ax square is equal to u, then du upon dx becomes 2ax and dx becomes du by 2ax, right? For one more substitution, we can write that x becomes square root of u upon a. Now putting this back in our integral, we end up with 2 times integral from 0 to infinity of x square e to the power minus u du upon 2ax, right? So notice that 2 gets cancelled and x gets cancelled out, and we end up with integral from 0 to infinity of x times e to the power minus u du upon a. Now we can substitute the value of x from here and put this back in the integral. We'll get integral from 0 to infinity of square root of u upon a times e to the power minus u du upon a. Now notice we have a times square root of a, so we'll get 1 upon a raised to the power 3 by 2 times the integral from 0 to infinity of u to the power 1 by 2 times e to the power minus u du, right? Now we are going to use the gamma function over here. So what is gamma function? Now gamma function is defined as gamma of n equals integral from 0 to infinity of some variable u raised to the power n minus 1 times e to the power minus u du. There's one more property of gamma function that we'll be using, and it says that gamma of n plus 1 equals n times gamma, right? Now these two integrals are going to be equal if somehow n minus 1 equals 1 by 2. That is, if n minus 1 equals 1 by 2, then n equals 3 by 2. So now we can write this integral in terms of gamma function. How? Let's see. This integral becomes 1 by a raised to the power 3 by 2 times the integral from 0 to infinity of u raised to the power 3 by 2 minus 1 times e to the power minus u du. Now we have converted this integral into the form of gamma function, right? From here you can compare that n is equal to 3 by 2. Therefore the solution to this integral would be gamma of 3 by 2, right? So the overall solution becomes 1 upon a raised to the power 3 by 2 times gamma of 3 by 2. So now by using the second property over here, we can write that this becomes 1 upon a raised to the power 3 by 2 times gamma of 1 by 2 plus 1, which would eventually become 1 upon a raised to the power 3 by 2 times 1 by 2 gamma of half, right? And you should remember that gamma of half is actually square root of pi, right? So our overall solution becomes square root of pi divided by 2 times a raised to the power 3 by 2.